here. Today we have 5 presentations for you. Our first one with our group sponsored by Arista, we're going to go over VXLAN and EVPN to make your data centers better. After that, the Department of Defense group is going to go over how AI can help with CMC compliance. Following them, the Heartland Business Systems group is going to talk about building a network built on identity services. After that, the Menards group is going to talk about how automating VMs can optimize your workplace. And finally, the second Arista group is going to talk about how you can automate your network with Nautobot. So, welcome to modernizing data centers using VXLAN and EVPN. So on our agenda today, first, we're just going to go over introductions to us and our sponsor, Arista. Following that, we're going to go over the problem statement, as well as our project deliverables. From there on, we're going to show you our lab environment, and from then on, we'll go over some key technologies, as well as our topology. We're going to do a live demo for you. Following that, we're going to talk about the challenges we went through doing this project, and then we'll open up the floor to questions. So, I'm Brandon Rupels. I am the project's co-lead and communications lead.
I'm Josh Gerhards. I am the quality assurance lead and a network specialist.
I'm Dylan Shackleton. I'm the networking lead and operations coordinator.
And I'm Sam Wilde. I was the other project co-lead and the other network specialist. Our sponsors today are, you know her, you love her, some of you were educated by her. Holly Yuan, she is our program director for our CNIT program, as well as our cybersecurity program. She was a great resource in helping us get our group together, get things situated for our Capstone presentations today. Our other project sponsor is Will Goss. Would you please stand up and be recognized? Hello. He is our, he works as a systems engineer at Arista, so for all of our questions, if things got a little too complex for our baby student brains, he was there to kind of guide us in the right direction, and he's just been a great help in our putting together a capstone. Our corporate sponsor is Arista Networking. You might have heard of them. They were founded in 2004 as a Raster Networking. They specialize in what you're going to see a lot of today, cloud networking within data centers. In fact, as of Q4 2023, they are the highest sellers of these kinds of switches that you're about to see today. If you're not really specializing in data centers, then they also do a lot of stuff with campus area networking and good old Wi-Fi. So nice to have a little bit of diversity there.
Right. So as we all know, time is money. And in the elden days of networking, it was commonly considered that single vendor networks were definitely cheaper. You could get good deals. And back then, the technology wasn't as advanced. But as over time, as we've gotten new technologies and our networks have gotten more complex, multi-vendor networks have become more common. It is not unrealistic to have one office in your company be running Cisco, another office running Arista, and then having a storefront running on Juniper. In fact, this is becoming more and more common year after year. According to an enterprise study, 59% of companies need to use multi-vendor networks just to suit their technical requirements for their business needs. For example, whether it's 5G wireless or integrating IoT technologies into your business, not all of those are provided by the same company. So multi-vendor is mandatory for those companies. Additionally, another 54% of companies have site-based requirements. Simply speaking, some companies don't make networking equipment that is satisfactory to work in a factory. You might make office switches, but the moment they need to be in hard industrial settings, might not work. But with the rise of multi-vendor networks supporting our businesses and raking in cash, they've also brought in problems. For one, using multiple vendors means you have to deal with compatibility issues. You have to hope that your technologies on one vendor will work on other ones. And as we keep adding vendors, this becomes increasingly complex as you have to go through manuals after manuals of lots and lots of rules to make sure everything works. And part of this is also going to create security mismatches. It is not unheard of that IoT devices don't have very good security policies on them. Whether it's a fridge monitor or a smart fridge, in your businesses or at home, lots of security issues. And ultimately, both of these combine together to create serious downtime. And if time is money, then downtime is burning your money. So how do we address these issues with multi-vendor networks so we can keep improving our networks and bringing in more money for our businesses and reducing costs? Well, that's what we're here to talk about today. Our solution focuses on two central pillars. The first is interoperability. All of the technologies we're going to talk about are open standards. They can work on any vendor. And that's important because we want our devices to work like how two strangers can sit down at a cafeteria table and walk away as friends. We want them to plug together. We want our configs to work seamlessly. And finally, we also wanted to have simplicity. We want these solutions to be things that you can implement within a couple of hours and they'll work fine. We don't want long, complex manuals. Open standards help keep things simple. And now I'm going to hand it to my friend Josh to talk about our deliverables.
All right, so we deployed a virtual leaf-spine topology in Container Lab to model a modern data center. This design with each leaf switch linked to each core switch ensures high availability and scalability. It also reduces cost by minimizing the need for any high-end core switches, and the predictable traffic patterns in this topology means it's easier and cheaper to scale compared to traditional networks.
All right, now I'm going to talk about our project goals. One of our project goals was to design and deploy a virtualized layer 3 leaf-spine data center design. We did this by leveraging EXLAN and EVPN to encapsulate layer 2 frames and layer 3. The next one was deploying professional skills and industry connections. And the third one was to practice engineering and presentation skills.
All right, so I'm going to guide you through our lab setup. Right over here, you can see a picture of our topology, and a tool some of you might have used is called Container Lab. Going into what Container Lab is. Wait. That is not the order I go in. Going into what Container Lab is, it's run as a Docker container. So we're able to basically virtualize our entire network simulation, which is great because we weren't tied down to a classroom lab. We could work on this at home, we could work with this in student union, we could work on this on bed, and so we'll cover it in strawberry Pop-Tart crumbs. Some of the other things we use to help us out in this endeavor, if we could go 2 slides back, I'm sorry, this is kind of out of order. This is basically run on a Google Cloud instance. Hands up if you've ever used Google Cloud before. I'm seeing a few good hands. All right, perfect. So you should probably already know that it's a resilient accessible platform that you can use to deploy whatever you want for whatever purpose. It enabled us to have like redundant testing environments. Say one of us wanted to run some like weird experiment or needed to fix an error. That was great for us to just get a different testing environment going and going from there. And also gave us complete mobility because again, we like flexible working platforms. Other than that, we also used GitHub. Should have no introduction. It was basically a project source of truth. It allowed us to make our own personal branches. And it also enabled us to have our own version control. So, moving on.
All right, now I'm going to talk about what VXLAN is. VXLAN was designed to address scaling issues in large multi-tenant data centers. It is an overlay technology that creates virtual links over a physical network. It is an open standard that's supported by pretty much any big national vendor like Cisco, Aruba, Dell, and of course Arista. It does this by encapsulating layer 2 frames within a layer 3 UDP packet using typically port 4789. It expands this. This is important because it expands the VLAN from the 4094 all the way up to 16 million. It, of course, supports MAC address learning, and some of the use cases is cloud provisioning and data center interconnects.
And on to head-end replication. So VXLAN needs a way to handle broadcast, unknown unicast, and multicast traffic, or BUM traffic. BUM traffic can be inefficient in data centers because it's difficult to configure, it's unreliable in virtualized environments, and it requires extra protocols which add complexity. Head-end replication avoids these issues by replicating BUM traffic as unicast traffic at the source VXLAN tunnel endpoint, or VTEP. It sends this traffic directly to each VTEP in the VXLAN segment, And this makes the network easier to manage and scale reliably without any multicast support in the underlay network. While hand-in replication provides a static method for handling VTEP communication, Dylan will go over a more dynamic approach with EVPN.
Okay, so EVPN is a standard-based control plane. It is, again, supported by all the main vendors you could possibly want. It typically leverages BGP for VXLAN. It provides a robust and scalable way to manage the VXLAN overlay. Some of its characteristics is MAC address learning through that BGP address family using the MAC VRFs. It bridges layer 2 and layer 3 routing. And it is, of course, scalable and flexible, just simple neighbor statements. Some of those use cases is data center internet interconnects and cloud and virtual applications.
Right, and MLAG, or multi-chassis link aggregation, provides multiple benefits. It links two of the switches to act as one logical switch for any device connected to the pair. And instead of relying on spanning tree and disconnecting one of the redundant links, it creates two active connections between the host and the paired leaf switches. This way, both connections can be used, which provides more throughput.
Then, to cap off all of our technologies, is that part of this project was also being able to manage this network from an easier way to make things more simple. And so, having gained access to CloudVision from our sponsor, Arista, this was the network management tool we chose to use. Whilst it is proprietary, it should work with most network products that were made in the past 8 years. So no matter what network you have, this tool should probably work on it. And CloudVision can do a lot of different things, but we're going to focus on two important key points for our project. The first is the unified management. All of your devices are in one easy place, all accessible, and as you're going to see, you can easily switch from one device to another and look at information in a matter of seconds. Additionally, it gives you excellent network observation. Any changes in your network can get picked up within seconds, which is also something we're going to demonstrate. And now I'm going to hand it off to Sam so he can point out how these technologies fit into our topology.
All right, so as you can see, this is our leaf spine architecture. Just going to go over kind of what Josh and Dylan mentioned and how that interacts with our thing. So first up, it is MLAG. So as you can see, our hosts, as Dylan said, these are two active links between two switches right here that are one logical unit. And of course, with me saying one logical unit, you might be thinking, well, how is this different from stacking? Basic differences are the control plane is entirely independent, unlike in traditional switch stacking. Also, you are not limited to the speed of your slowest switch, which is very nice. Moving along, we have VXLAN. So VXLAN extends VLAN. As you can see, it allows us to basically make a tunnel through our leaf switches between our end devices. It works a little bit like how, basically, kind of like how UW-VPN does, except basically you don't have to, the thing is entirely encapsulated, and the spine switches basically don't see the inside of the traffic, they just see where it's going. Moving along, we have EVPN. So as you can see, it basically creates a overlay network using BGP. It maps, it kind of combines layer 2 and layer 3 routing by mapping individual MAC addresses to an IP address, which allows for just much faster routing within data centers, and it just, it's very good for that. Moving along, we've got our live demo. So if we would rearrange a little bit here, Dylan is about to transition out of our presentation and into our Google Cloud environment. So as you can see, that is our Google Cloud instance. If you would like to click into that. You don't have a menu, you might already spot some of our specs that we're using for this virtual machine. It's 8 vCPUs, it's 32 gigs of memory, and it's a disk of 20 gigabytes. Could it have been less? Probably. This is just what Arista recommended so that nothing totally, truly broke immediately. So if you would please use port 22 to get quite a few commands. The one that we use to actually set up the thing, if you could go back into history and hopefully people in the back can read that. It says sudo clab redeploy -t and then a YAML file that basically sets up our entire virtual network. And because that command takes about 20 minutes to run, we've already fully set this up in our environment. So Dylan, if you could please tab over to that. And then what you are looking at with admittedly little dense labels, we were never able to figure out how to get rid of those. You can see our active and live topology. So Dylan, if you would like to show off some show commands inside of our individual devices.
Okay, yeah. So some of our show commands, we're gonna start on the leaf. We're gonna show how first we're gonna show the underlay, showing our just simple BGP neighbors. So here are our spines. They are our VTAPs. They are connecting all of our leaves together so they can switch everything at whenever they need. Next, we're going to transition to showing what our EVPN looks like. So these are all the EVPN neighbors. These are just the spines, but these are the ones that are configured using EVPN. They are the VTAPs for our network. They advertise the VNIs out through each of the participating leafs. All right, next we're going to swap back over to the host. And we are going to do a trace route between host 1 and host 2. But this will be going through just the standard BGP network to show what it looks like before and kind of an after this one. We should see some. All right, and so this one's going to show us each of the hops between. So first we're going to see the leaf 1, leaf 1 in this case. Then we're going to see spine 1. Then we're going to go to spine 3, and before it hits our host. Now, if we leverage the EVPN fabric, we go from 3 to 4 hops down to just a single hop. So this just completely makes the network way more efficient, and although the physical device is right there.
It may not be the most, flashy of demonstrations, but when we cut down 3 hops to 1 hop, you're effectively making the network run a lot faster. And on data center numbers, something as a few less hops multiplied by the billions of packets, or even trillions, that might go through a data center every year, can mean millions and up to billions of extra dollars of work done. So whilst this isn't the most flashy of things, it is quite possibly something that could make your business do far more business with its network.
All right, and then I will wrap it up one more time with one more show command just to show that we are learning stuff. And here is that we're seeing that we're learning that MAC address from host 1 on VLAN 100 through our EVPN, on our VXLAN, and here is its VTAP it is going through, and it is showing our 1 move. All right, now I will transition off to Brandon and Josh to show us our CloudVision demo.
To start the CloudVision demo, we will demonstrate some of the telemetry features of CloudVision. So we're just going to make a small change to one of our switches, just updating the host name. After we update that name, it should update in the CloudVision device inventory pretty instantly. And eventually we will also get an out of compliance icon here. If we click on that, it gives us a side-by-side view with the designed configuration on the left and then the running configuration on the right side. And that makes it easy to notice any changes and decide if you want to roll back or push changes. Next, we will take a look at a few of the key tables on the switch. So if we go into the ARP table, it shows us our resolved IP addresses with any changes to the table on the right side. And then we can check on the mleg status here, and that confirms that the leaf switch is paired. And then the VXLAN table, this shows which VNI is paired to which VNI. So these tools make CloudVision powerful for monitoring and validating configs and troubleshooting in real time. Next, Brandon will go over CloudVision's topology and configlet features.
So another neat thing about CloudVision is that when you upload all of your devices to it, is that it will automatically build out a topology for you based on your setup. So if you add another switch to your network and you add it to CloudVision, it'll automatically just put it in. So we'll expand this out. Now, our sponsor, Will, has graciously allowed us to look at a mock production environment for part of this demo. So going to thank him for that. So when you're looking at your topology, you have the ability to change overlays to look at your network. So for example, if we want to look at discard rate to see how many packets are being lost, well, we can see that in this mock production environment that we have some severe packet loss coming from some of these rack servers. So we can expand said cluster, and then we can pinpoint to which server is having all of the discarded packets. And we can do that for both of them. This is just one of many different overlays you can use. You can also see the speed of the links. So for example, these darker purple ones are much more faster 100 gigabyte ones, where the ones that we're using in our environment are just some generic 1 gigabyte ones in Container Lab because we don't need anything more than that. Another key part of this project was making basic configlets. So configlets are little pieces of network configuration that you can use between devices if you want to use them as presets. So let me pull up the topology view here. So here you can see our network is separated into different little parts. Each of our leaves has its each little part here, and a yellow device means that a change has been made to the configuration that hasn't been saved in CloudVision. So I'm going to demonstrate adding a little configlet to our border switches. So what configlet we're adding is going to be our demo configlet. So we update it, and then we'll save it so that way the changes are committed. So before we fully, oopsies, page is a little too zoomed in. So before we actually fully commit that task change, I'm just going to show you what that configlet was. So that is just a basic configlet that will add a little banner of the day. This nice, fun little skull that says you're not allowed to be inside. So when we want to actually commit that change to CloudVision, we go to tasks. And you'll see that that little change I made is right here with both of our border leaves. So we'll select both of them and then create a change. So you can do changes in a variety of ways. You can do them in series, which means it'll go device by device. If you're doing some major changes, you'd want to do that. So that way you don't take down your whole network by accident. But for something like this, we can just do parallel, which is all at once, and it's much faster. You can also make your own templates for that, but that is beyond the scope of this. So after selecting it, it'll go over the change. And if we look at configuration changes, we can look at the difference, adding our cool little skull. So we can hit review and approve, just to show that's all going well. We'll get some configuration warnings about things that might break when we do this, but they won't because we've done this before. So I'll hit the execute immediately button just to speed this up a bit. So it'll start making the changes in about 10 or 20 seconds. It'll go through the process, approve, start, and it will complete. So this is a very nice tool because you can use this to stagger how you make your network changes. You can use a variety of configlets to do a variety of things. Some of our normal switch configurations are just saved as other configlets. Yep, so as you can see, our change has been committed. Now CloudVision now wants us to have the skull. But unfortunately, our boss just caught us slacking off on the banner of the day and has called our skull unprofessional and wants it to go away. Well, with this little rollback button, everything we just did, we can just select the devices, and it's like it never happened. So as we wait for the create rollback change to go through, it'll go through, everything's rolled back, and it's as if nothing ever happened. And that will conclude our live demo. So we'll go back to Josh to start talking about the challenges we've had with this project.
So one challenge that I faced was balancing priorities, both in my personal life and as the project needs shifted. I found that being adaptable was important to stay engaged and contribute effectively. And this flexibility will be valuable in any future roles where priorities shift quickly and teamwork is important.
All right, some of the challenges I had was VLAN mapping to VNIs. At first, a lot of the help guides and configurations were pointing me in a direction that was just misleading. A lot of them used the ASN number in the VLAN number to just tie them all together, which kind of works, but it just kind of makes a lot of problems at the end. I did figure out that it just makes more sense to make them match. They should just match on both sides and everything's happy. Another issue I had was MLAG inconsistencies. There was, at the beginning, we had a lot of issues trying to keep the switches consistent between the two MLAG pairs. Every time I would change something, it would just break every single time. So I got into the habit of having both switches open side by side, and just if I changed one, I changed the other immediately.
And some of the challenges I ran into while working on this project were a lot like Josh's. I also had to balance a really busy schedule. I'm sure most of you have been college seniors before. Trying to balance a full part-time internship and classes and extracurriculars was not fun trying to balance this in as well. That and coming from a near purely Cisco environment in both my classes and in my internship did come with a decent learning curve. Trying to learn more virtualized environments. Mostly the lesson I had to learn is that it's okay to ask for help because you're not your own person. You're almost always working as part of a team, and the three other guys here have been amazing to work with. So, moving on to Brandon.
Right, so another interesting network challenge we had is that our cloud vision would immediately break every single time that we'd redeploy our network. And the reason why was because every time we'd redeploy our topology into Container Lab, all of the MAC addresses would be completely new. So we had to find a way to fix that. And so it was rectified by a command in the virtual machine that Will helped us create. So highlighted are all the MAC addresses of our devices. We had to use this command to tell Container Lab, hey, every time we make this, you give this device this MAC address. And once we did that, every single time, it would reappear in Container Lab, and it worked like a charm. So as for non-technical challenges for me, this is my girlfriend Elaine, and we have been dating for 2 years. So I've been at Stout for most of that time, so long distance makes a pretty big, it's a serious challenge. So working on this project for the past few weeks has put a lot of strain on time I can devote to her, time I can devote to the project, time I can devote to other classwork, and it was difficult. There was a lot of hard days, and there was a lot of communication, and ultimately we supported each other through it. And today we are actually celebrating our 2nd anniversary. So we'd like to thank all of you for coming here today. We'd like to once again thank William Goss for being an excellent, wonderful project sponsor, an absolute pleasure to work with him. We would like to thank all of you for coming. Your attendance is appreciated, and we're very happy to show you all of the work we've done. We'd also like to thank Holly for advising us through and for being a great program director and an excellent role model in our field. And we'd also like to thank the UW-Stout administration for allowing all of this to come together. So, with interoperable technologies, you can make your network simpler and easier to operate between vendors. And as technology develops, we hope that we can keep learning these things and adapting them into our networks so we can make them work even better. So we'd like to open up the floor to some questions. Any questions at all?
I'll ask a question. If you could go back to your trace route tab, I noticed something interesting, and so maybe it's maybe a unique question. If you could go back to your trace route tab
Let's see.
in your presentation.
Do we have a traceroute tab in the presentation or the live demo?
Live demo?
Yeah, the live demo.
Okay, yeah, we can go back to that.
I noticed that if you look at your single hop, it has the same latency as what the 3-hops had, right?
Right.
So I was curious why that would be.
That's just due to the virtualized nature of it. They're not the most isolated machines. They share the same resources. There's a little bit of overhead. But otherwise, because it does a little bit of encapsulation as well, but otherwise it should just be.
Yeah, it would normally be faster in a proper network environment, but because we're running it on a virtual machine where they're all sharing the same resources and it's not a very hefty one because we didn't want to like use our whole cloud budget on a very expensive VM. So they're all just kind of sharing resources. So in a natural lab environment, it would like be faster, but in this case, it's about the same just because of the shared resources. Any other questions? Well, if there aren't any more, well, up next is the Department of Defense capstone.
Well done.
I don't know. Who was doing it last time? Because last time we did the practice, it was fine. I mean, I feel like
tap in the thing.
I need the laser though. Oh yeah. I can just press from over here.
Testing. Hello everyone, we are Control-Alt-Comply, and for this year's Capstone project, we were tasked with prototyping a CMMC manufacturing network with AI in a hybrid cloud. Getting into our sponsors, we are sponsored by the DoD Cyber Service Academy. Getting into our team, I am Peyton Braun. I am the team lead. I am also the AI engineer as well as the documentation specialist.
I am Owen Praga. I am the security engineer as well as a AI engineer.
And I'm JJ Hansen, and I was network engineer as well as a content developer.
Now getting into our sponsors. We are sponsored by the DoD Cyber Service Academy. They are the part of the Department of Defense who helps with education in cybersecurity funding. We are also sponsored by Dr. Holly Wan. She is the program director for both CNIT and cybersecurity here at Stout, as well as a professor. And we are also sponsored by Brandon Cross up there. He is our advisor for this project and also a professor here at Stout. And so, getting into our agenda for today, we'll be going over the foundations of our project, along with what is CMMC. We'll be going through the challenges that small medium business manufacturers face with CMMC. We'll be going through why we focused solely on CMMC Level 2. We'll be looking at our project overview. We'll be getting into our live demo. We'll have some closing remarks, and then we'll open up the floor for any questions. And so as we move into our project, we wanted to give you a brief history of the beginnings of CMMC.
So really, it all started back in 2007 when defense giants Boeing, Lockheed Martin, and all of their subcontractors had a multi-year-long data breach, leaking over 65 gigabytes of classified information pertaining to the F-35 and F-22 fighter jets. Shortly after we learned about these breaches, China just released their new J-20 and J-21 fighter jets, which had a shocking similarity to the American counterparts. With China being behind these attacks, they were able to produce these jets in a fraction of the time and with far less money than the United States did. And we later learned that all of the security breaches weren't from the poor security practices of the large giants, but the poor security practices of the small, medium businesses that were all the subcontractors. So what did the United States learn from these attacks? Number one, they learned that big companies aren't the focus, but instead focus on the small, medium business manufacturers that do not have the skill set and or monetary funds as the large defense contractors. And then they also learned that there had to be more legislative protection against federal contract information and controlled unclassified information.
So getting into a brief history of CMMC itself, it all started in 2015 with the release of NIST 800-171. This was a self-assessment of your cybersecurity standards. It had 14 control families, 110 controls, and in this instance, a control is a rule or safeguard put in place to protect both federal contract information, FCI, or controlled unclassified information, that's CY. And in 2017, the DoD, under the DFARS mandate, made this a requirement for all DoD contractors to meet. And as this was a self-assessment, we soon realized that most companies, in their best interest of money, would not comply with these and would say they're in compliance, but in reality, they were non-compliant. And in 2018 and 2019, we saw lots of data breaches. One of the biggest of these being Project Sea Dragon. This was a project that the Department of Defense was working on to create anti-ship missiles on submarines. This project cost over $300 million in research and development and ended up being a data breach because those small, medium business manufacturers were using non-compliant storage, and that's led to the loss of over 614 gigabytes of classified or controlled unclassified information.
Yeah. So after the downfall of Project Sea Dragon, the Department of Defense introduced the Cybersecurity Maturity Model Certificate in 2020. This was released with 5 total levels of certification. There's no self-assessment for any of these 5 levels. You needed a third-party assessor for all 5. There's a total of 14 control families and 110 total controls. And the DoD quickly realized that this was too strict and too difficult to understand for small to medium-sized businesses, which is why they introduced the Cybersecurity Model 2.0. This was released in 2021 with 3 total levels of certification instead of 5. Level 1 being a total self-assessment, Level 2 being a third-party assessment, and Level 3 being a DoD assessment. There were a total of 14 control families and 134 total controls. And this was found to be less strict and easier to navigate for the small, medium-sized businesses, mostly due to the plan of action and milestones, which allowed companies to slowly implement all their controls. So we've talked a lot about controls. So here's an example of a control. So the IA there stands for identification and authentication. This is the control family. The L2 stands for level 2. And then the 3.57 is the control identifier. And then the A through D you see there, those are the control objectives.
So CMMC 2.0 doesn't come without its challenges. Number one, it's very complex and very time-consuming for a bunch of businesses. And also they lack a bunch of documentation and guide examples. So it's very hard for them to start their documentation. It's also very costly for a company, as the average cost of just the assessment alone is around $50,000. And the Department of Defense estimates that it costs companies $100,000 to be fully compliant. And from our experience, we found that that is on the lower end of things. So how does our project help companies achieve their certification? Number one, we have built an AI with real-time responses to queries. We also have a greater than 85% mapping accuracy, as well as we created a bunch of training presentations for companies to learn more about CMMC, as well as examples of a hybrid network throughout our documentation. And finally, we have example CMMC at level 2 documentation and guides and implementation.
And so now we'll get into why we focus solely on level 2. As you heard, there are 3 levels. All 3 levels build on each other. Level 3 is way too big for most small, medium businesses. So we focused on level 2 as it's a large jump from level 1 as we get into CUI compliance, the controlled unclassified information. This in level 2 goes off the NIST 800-171 document again. With the 110 controls and total 320 of those assessment objectives. In this, we saw the introduction of C3PAOs, also known as the Certified Third-Party Assessor Organizations. So these organizations would come into your network, make sure you meet the requirements of CMMC Level 2, and go through your assessment guide. They would also introduce the idea of continuous monitoring of compliance. So CMMC is not a single certification, you're good to go forever. You need to prove that you meet this compliance at all times. You need to have the logs to prove that you're meeting this. And as we believe, this is the most impactful level, as level 1 is a self-assessment. Again, like we've said, level 2, that really brings in the third-party assessment. So that's a big jump for these organizations. The documentation jump is huge, and that is why we believe it is the most impactful for small and medium businesses. And as we get into the documentation requirements for CMMC Level 2, the biggest document that you need in a CMMC assessment is your System Security Plan, or an SSP. This is your lifeblood of your entire assessment. You also need a Plan of Action and Milestones, also known as the POAM. You need all of your policies and procedure documents in place, ready to go. You also need an asset inventory of any device or anything on your network that is going to touch both FCI and CUI. You need to have an in-depth and proven incident response plan ready to go. And you also need an access control list of all users that are going to be able to touch those devices that touch FCI and CUI in your network. And you need to make sure that you have the training records that prove they've passed the DoD required trainings.
So onto what Peyton mentioned about the SSP. What is an SSP? An SSP is a system security plan, which is basically outlines an assessor's guide to your network. It basically tells the assessor how your organization meets all the security requirements. It includes a couple key things. Number one, network diagrams of your network explaining in-scope versus out-of-scope assets. Anything that's not CUI or FCI, we don't care about. So then we also need flow diagrams of how CUI and FCI move throughout your network. We also need security policies that an organization has in place, as well as system configurations that will map to those security policies that your org has in place. And then finally, and most importantly, you need proof that these security policies and system configurations are in place.
So now we get into the big part of our project, was building the AI to help these companies get certified. What are some of the things it can do? The big one is if you have a CMMC level, any question around CMMC, you're able to ask this AI and it's able to give you a good understanding of how that works. It's using our official NIST documentation, as well as all of the documentation we have built on the back end. We have over 900 pages of documentation built for CMMC level 2. And other related documents that are from NIST for CMMC level 1 and level 3 for those easy intro questions. This AI is also able to help you build that documentation. So as we've said, there's a lot of documentation required in this, and it's a lot of work to go in without knowing how to do this. So the AI is able to help you build those documents with our templates. It's also able to assist in self-assessments. So as we talked about, that plan of action and milestones, as you go through getting your network secured, you will have your plan of action and milestones being built out for any controls that you find don't meet your system security plan. And you can have those there so that your assessor is able to see that you are proactively looking at the CMMC controls. And it's also able to give you example implementations. We have example implementations for every single control and assessment objective in CMMC Level 2. So again, if you need help with anything, if you want, as we'll show in the live demo, we'll be showing you some Windows implementations.
And then finally onto our lab setup. So another one of our deliverables for this project was to create an entire network so then we could help learn and implement all of these controls. It includes our virtual network that we have here at Stout, which has two Windows servers forming AD, DNS, DHCP, all of that jazz. It also has a Linux machine serving as our inventory management. We also have our 2 Palo Alto firewalls, for firewalls of course, and then as well as the couple Windows 11 hosts mimicking our engineering users. And then on the AWS side, we have IoT Hub and Lambda, and then that will process all of our mock manufacturing data, as well as IAM for all of our user management and role management. And then finally, S3 buckets for the backups of your critical servers, as well as storing all of that process manufacturing data.
All right, so this is the lab topology we have for the network that we have set up here at UW-Stout. We have the 2 Palo Altos serving as our firewall and router combination. We have 2 core switches, and then we have 2 access switches. One is for management in our servers, and the other is a hypothetical manufacturing floor that we don't have set up here on premises, but it's something that you'd see on an actual manufacturing network. So we thought that was useful to include in there.
So now, as we work our way into the live demo, while Owen gets us set up, as CMMC is something that's continually being implemented and a big part of the DoD, we have some recent news. I'm sure some of you know the giant contractors Raytheon and Nightwing. Both of these companies are recently fined $8.4 million for non-compliance with CMMC between 2015 and 2021. They did not have an SSP in place, and they were also caught falsifying CMMC documentation. And so, as we can see here, this is our AI assistant. So, as we can see, we're going to talk about the Windows environment. We'll be going through controls 3.5.7 and 3.5.8. This AI is able to go through our knowledge base, so it is going to go make sure that these controls exist in CMMC Level 2. If they do not, it will not answer your question. This AI, again, is an AI tool. So once we get through here, we are telling you that this is a tool. Remember, CMMC is a government compliance. The AI cannot do this for you. You must understand what you're implementing, what you're putting in your documentation. This is just a tool to help you out. So as we can see here, 3.5.7, we are going to be looking at password complexity and change requirements. So it's going to give us a Windows-specific implementation help. So we're going to be looking at enforcing a password history of 24 remembered passwords, maximum password age 90 days. We're looking at a minimum password length of 12 characters, and we must meet the complexity requirements. So in Windows, they have a GPO pre-built, so that is you need to meet 3 of the 4 requirements, so a uppercase letter, lowercase letter, a number, or a special character. And as we get down, it'll tell you what you might need to show that you meet that GPO requirement, or that control requirement. And in 3.5.8, we need to make sure that our account those GPO settings are also in place inside the Windows server to make sure that the accounts are not able to be re-gotten out. And then if we go into the Windows server itself, we can see that the example documentation the AI gave us was able to help us create a GPO here. So we can see 24 passwords remembered, if we remember that. The 12-character minimum password length, as well as the password complexity requirements right there. So again, that's pre-built into Windows, meeting 3 of those 4. And we can run the command net accounts to see what GPOs are in place on the server itself. And so we can see they are enforced, that we have the minimum password age of 1 day, the minimum password length 12, the password history 24, all that good stuff that we would seen in the AI's response. And now we can get into the actual example of the SSP. Again, like I said, we have over 900 pages of documentation. This is one of our documents, the System Security Plan. It is a 175-page document. This walks you through every control that we have. So in this case, 3.5.7 again, we see in our SSP, remember, our SSP says 12 characters must meet 3 of the 4. And again, that is something we implemented. And in order to show that, we have to show a screenshot down in our artifacts section. So again, this screenshot here proves that we are meeting this control. In this case, in 3.5.7 and 3.5.8, we're using the same screenshot. So some of you might think, well, if we have the screenshot in 3.5.7, we don't need it in 3.5.8. That is not the case. We need this screenshot in both because this is compliance documentation. It has to be proven for both situations, no matter what. And now we can get into some training examples from JJ.
Yeah, no, we're good. So one of the key deliverables for this project was to create updated training slides. So this one is an example of 3.5.7. So this is just the assessment objectives. And then the next slide is just a case study example. So this is a slide I created. It's a lot of what they just talked about, setting the minimum password length to 12, including uppercase, lowercase, and special characters. And the main goal with these were just to create real-world environments showing and giving a good example to people who might be wanting to learn about it. And then next, we also created activities and quizzes. So this is an example of an activity that I created. You're given 5 different assets, and you have to identify whether it handles CUI. And then you had to also determine what it should be classified as. And then here's an example of a quiz. So this is just a simple 3-question quiz. Our goal with these were just to create like hands-on and interactive activities to help people learn about CMMC.
So in wrapping up the demo, we got a couple lessons learned that we have had throughout this project. Number one is to focus on the deliverables. At the beginning, I know me and Peyton, we were all very focused on the ooh shiny, ooh what if we did this, ooh what if we did that. We later learned that compliance is very large. So after a while, we learned to focus on the deliverables, get it all set up and going before we could do all of the ooh shiny later. We also learned how to use the tools to help make the tools. We're building an AI-generated documentation. So what we could do is we could pipe all of the fancy government level documentation and then use the AI to help us digest it and then learn it and then of course reference it to make sure it is all correct. It also takes a bunch of time to refine AI, as some of you may know. It likes to do stuff that you tell it not to do. So it took a lot of time to refine AI. We thought we could just throw documents in there, it'll read it, and it'll perfectly match what we needed to. But as it turns out, that was not the case. We also learned that compliance is huge and that it takes tons of time to implement. We're barely scratching the surface here. And it really, we thought we'd have this like all done within like a couple weeks. Oh, easy peasy. And yeah, it's massive.
Yeah. So now moving on to the business reflection. So our AI is going to help accelerate compliance by streamlining control mapping, documentation, as well as assessment prep. It is also going to simplify compliance by guiding users through controls and assessment objectives. It is also going to strengthen security by making sure you don't go over any of the small little details in the objectives and stuff like that. And it's also going to save you money by eliminating the need for any third-party help you might encounter.
So now as we get into our growth and challenges, we had a couple challenges throughout this project that we thought we'd share. One fun one was our ESXi host server really did not want to comply with us at the beginning, but as we started putting some work in, the server decided to stop crashing on us randomly. And for the last month, after we started putting in controls on the system, it's really started to comply with us and not crashed at all in the last month. So that was very helpful for getting this project ready. The other big challenge we had was AI hallucinations. As Owen brought up, the AI did not like to do what we told it. And I'm sure all of you have used an AI model at this point, and I'm sure all of you have been lied to by an AI model, and it is probably the most confident thing in the world when it tells you the lie. For our case, we were able to get the AI hallucinations down by locking down the AI to only our official documentation from NIST and our documentation we created for this project. This allowed us to lock the AI down so it wouldn't answer questions outside of that. So if you asked anything about level 2 or level 3 that included a control, it will tell you this is not part of my scope. I'm not able to answer that question. And on top of this, with the 85% MACME accuracy requirement that we had went through at the end with a 75 question test suite and had a mapping accuracy of 96.7%. So we believe this AI is good enough for a real world environment. But again, this is an AI. It is not your be-all, end-all of CMMC compliance. The next thing we had trouble with was navigating official documents. I'm sure, as all of you know, official documents are made for industry professionals. We are still students at this point, hopefully soon industry professionals. So understanding these documents was a very big challenge. And again, as we started going through the trainings we've gone through, and getting the AI ready, it really helped us understand these documents and helped us get an idea of what we were actually doing. And the next big challenge for myself in particular was sanitizing an SSP. An SSP is very proprietary to your company. These aren't shared on the internet. These are not anywhere. There are no good examples online of a filled out SSP. I was lucky enough to have an internship at a company going through a CMMC level 2 audit, and they were kind enough to let me sanitize their SSP to remove all proprietary information. And as you saw, that document was 175 pages, and it had to go through 2 revisions, 1 sanitizing it, and 2 making it for a manufacturing network so that our AI fits the goal here. And so as we wrap up here, we'd like to say thank you to everyone here again. Specifically, we'd like to thank our sponsor, the DoD Cyber Service Academy, for helping sponsor this project, as well as Dr. Holly Wan and Brandon Cross for their incredible help throughout this. And we'd like to thank all of you for showing up and listening to us talk. We'll have the floor open for any questions. Yes, so that's the fun part. So our AI is trained specifically on CMMC Level 2 Revision 2. Revision 3, as it's approved but not in place yet, we decided to, as there was a lot of changes between them and getting the AI to work correctly, we would really have to make the documentation for Revision 3 separately, and we didn't have the time for that. So focusing specifically on Revision 2 is what our AI is on. Yeah, so I was working on that, and the problem is the revisions themselves, the documentation I had at that point from our SSP did not match the controls of revision 3. So that's where we ran into a lot of hallucinations, was when you're trying to go between those, and it kept trying to make up controls that didn't exist. Yeah, so the AI is able to, for those type of questions, it doesn't need to specifically reference our documentation. It can go out and help you answer that question using outside help, as an AI does. It can help you search the internet for that. So in our 75 question test suite, we tested some of those questions where it wasn't relatively in our documentation to see how well it would answer those type of questions. In that case, I don't know exactly what it's going to tell you, as it's the AI model, but in our findings, it was relatively good at creating those. So in that case, if I had to answer, it might find that 90 days is not a requirement, and as the time requirement in CMMC Level 2 doesn't tell you a set date, it would then tell you, if you don't want to use 90 days, it could tell you that maybe a year could be working and give you some reasons why that would work. The AI alone, between our testing of the ChatGPT model as well as the Llama model on AWS, is probably around 120 hours of that was just solely on the AI itself and refining the documentation to conform with how the AI reads the information. So that's about where we were at for that. Any other questions?
Just some feedback.
Oh.
As an audit professional from my career, you guys mastered the use of the word controls and the conceptual understanding. Well done.
Thank you.
If there's nothing else. If there's nothing else, we hope that you enjoy our next presentation by our friends over at the HBS Capstone Group.
The over-encompassing part of our project is developing everything a company would need for their IT. And with that, we have some specific deliverables to share with you today. That'll include some demonstrations of wired network access control, some wireless of identity pre-shared key, and bring your own device. We'll be talking about Veeam and disaster recovery, and doing a live demo of Cisco Duo.
All right, as my good friend Chad here mentioned, we want to build a proof of concept network for UDC. We want to enhance the security and compliance of it through the use of dynamic VLANs, our own internal PKI, and the use of Duo for logins. We want to centralize services through Active Directory, establish wireless and wired access. But ultimately, what does this all mean? It means our network is going to be efficient, secure, and resilient. And as I would think the theme of the day is, reduces downtime and saves UDC money going forward.
Okay, so thank you again to our friends at HBS. They've generously let us use the following equipment to build this network. We have, as you can see on the screen behind me here, multiple switches, fabric interconnects, blades in the chassis, nimble storage, etc. And using all of this equipment, we were able to build the following topology. So I'll just sort of explain this here. Starting from the bottom here, we've got our access layer with our wireless access points connected to that. And then moving up, we've got our core switches configured in a VSS configuration. VSS stands for Virtual Switching System. That's a Cisco proprietary technology that basically allows us to combine those physical switches into one single virtual switch. And then those are connected to our fabric interconnects, which are connected to the blade chassis and nimble that you can see up top there. And then everything's kind of connected to our management switch in the center there because we're using an out-of-band management system.
And here's what it actually looks like in our lab. We're using a picture before we cabled everything. But please feel free to assume that our cable management is very neat. Up top there, we have our 4 access layer switches. That's where our end hosts and APs connect to. And then below that, we have our core switch configured with a VSS link, like Chad talked about that. And then a really cool part of our project is below that, where we have our fabric interconnects that connect our blade servers with the nimble storage array. So the green circles there, that makes up our storage area network. And what that means is that the blade servers themselves don't actually have any storage on them. It's all compute power. And they're pulling any storage they need from that nimble storage array. And that's done over an iSCSI network that we configured as well. And then up top there, the fabric interconnects, the top green circle, they interconnect everything together. And that's where we can manage the system, spin up service blade templates, customize everything that we need. And then when it's all said and done, the servers boot from SAN, and we have them running Windows Server with Hyper-V enabled, where we then host our VMs with services like Identity Services Engine.
So what is ICE? ICE is Cisco's Identity Services Engine. It's responsible for managing network access security policies across wired, wireless, and VPN connections. Its primary function is AAA. Authentication is where a user or device is identified using protocols like .1x, MAC authentication bypass, or web portals. Once that user or device is identified, authorization determines what level of access is granted to them. And then accounting is all about logging. ICE keep track of who does what, when, and how, which tremendously helps for troubleshooting and things like auditing. And then beyond AAA, ICE also enables features like managing guest access, device onboarding for bring your own device. It can identify device types and health, and also enables security policies and network segmentation. So when talking about ICE deployment, the most important thing to understand is its distributed architecture, which revolves around its node personas. Each persona has its distinct role, which helps ICE in its scalability. The 3 personas are 1, the administration node, or PAN. This is like the control center of the ICE deployment. It's where all the configuration happens. You log into PAN, you configure policies, you register devices, you manage user identities. It's basically where you control every aspect of ICE. Following that is the PSN, or Policy Service Node, and this is the key factor to making everything work together. It's the direct point of contact, and you can think of it as the workhorse of the ICE deployment. So when a user device attempts to make a network connection, the network access devices, like your wireless LAN controllers and switches, will send a radius or TACAX request to your PSN. The PSN will then evaluate these against the configured policies sent from the PAN to make decisions about authentication and authorization. And then the last one is monitoring, or MNT. As the name implies, this persona is all about logging. Logging operational data, so like things like authentication failures, successes, alarms, system diagnostics, and basically any form of reporting like that. And lastly is where all the central brain of the decision making in ICE, or the policy sets. And you can think of these as a kind of folder. Within the policy sets, there's essentially rules, and they try to match network connections to certain conditions. These conditions can range from location, network type, or device type, or things like if a device is trying to connect to a certain wireless SSID. So for example, if a laptop is trying to connect to our BYOD SSID, it'll hit a different policy set than if a phone was trying to hit our guest SSID. And then once it meets one of those conditions, that policy set will take control over that connection attempt. And inside the policy set, there's two main things, an authentication policy and an authorization policy. The authentication policy specifies what protocols are allowed. And this is most commonly like EAP TLS, PEEP, or MAC authentication bypass. More importantly, it identifies it selects what identity source sequence you want to use. And this is what it authenticates against. So for example, if you're using .1x protocols, it'll most likely be authenticating against your Active Directory. If you're using MAC authentication bypass, you can set it up to authenticate against internal endpoints set up manually in your ICE deployment. And once that user device is verified, the authorization policy kicks in. And this is what controls what level of access is granted. So it can control what network resources you can reach. It can assign VLANs, it can assign ACLs, and it can also push URL redirects for any web traffic that's intercepted. So for our first demonstration, we'll go through the wired one from a non-domain joined computer. First, we'll see that an Ethernet connection is attempted. We'll sign in using Active Directory credentials, and you'll see that it attempts to resolve the DNS hostname. There it is, udc.local. This means we can access our internal network. So here we'll open up a web browser, and we'll attempt to reach our ICE network, or our ICE service. There we see we are successful, so we can log in, and we'll take a look at our policy sets first. You'll see that each policy set will have a condition, and what you'll want to look for in the condition is, in the wired one, is the specific connection type. So you'll see that it says radius NAS port type equals Ethernet. Because none of the conditions above match what we're currently doing, that policy set will take control. We'll take a look inside. It says there's two things, authentication policy. We use .1x and MAC authentication bypass. And then depending on if it passes, the authorization policy will assign an authorization profile, and that being our wired PC VLAN. And then here is our logs for this. This just shows our connection attempt. It says authentication succeeded, and at the bottom we'll see that it's successfully assigned a VLAN of 20.
And so a big security challenge that every company faces is employees bringing in their own devices. And we want them to have access to what they need on their network, but we also don't know exactly what's on those devices. So we need to protect the company network, right? And that's where the wireless and BYOD flow comes into play. So how that's going to work is the employee comes in, they connect to the UDC employee SSID that we have set up. They'll be asked for some credentials, assuming they have that. That's when ICE will check if their MAC address is in the endpoint ID group. In this case, it'll be a new user, so it won't be yet. And this is when they get actually redirected to the UDC BYOD portal that we made. And that's when their device will get registered to the endpoint ID group. And this is also where they install the Cisco Network Assistant. And the point of the CNA is to install a certificate on the device where they'll then re-authenticate using ETLS. So we can actually show how that looks here. The employee will come in, they'll connect to UDC employee. They'll be asked for some credentials, plugging that in there. And then what's happening first is we're checking that the credentials are actually correct, which they will be. And then ICE is checking if their MAC address is in the endpoint ID group. But again, this is a new device, so it won't be in there yet. And a user, they'll try to navigate to a website, say they're trying to get to one of our internal sites, which is 10.50. They get redirected to our UDC BOD portal. This is where they can put in their information. They'll just need a device name and description. The MAC address is added automatically. And what you just saw install was the Cisco Network Setup Assistant. And like I said, the point of the CNA is to install a certificate on the device. And what's the point of a digital certificate? It's kind of like having an ID badge that says this person can get into the office. So the CNA goes through the profile configuration, downloads the certificate, and in the bottom right, you can see the Wi-Fi symbol bouncing up and down. This is what we call our change of authorization. So we're actually re-authenticating, this time using EAP-TLS, as shown on the flowchart, instead of the PEEP authentication that we initially used that just used the credentials. So we can actually take a look at how that looks in Identity Services Engine. If we pull up the log, we're going to be looking for the authentication protocol that actually says EAP-TLS, so we know that they re-authenticated. We're looking for EAP-TLS there, authentication protocol, and there it is. And so a very similar network we have set up is our guest wireless network. We want guest users to come in and be able to get the access they need, which will just be internet access and not be able to get into any of our internal devices. So we can see what that looks like here. Employee will come, or guest will come in, find the guest SSID. If you'll notice, there's no password because all they need is connect to the internet, so they get connected. Let's make sure that they're on a network here. So they are 10.30 network, and then a similar thing's going to happen. They're going to try to go to a website, but they're going to get redirected this time to our hotspot portal. And they're going to read that acceptable use policy very carefully, of course, before they accept and get connected. So they've connected now, but let's make sure that they can't reach any of our internal services like a WLC and our ICE. So we just pinged ICE there. That doesn't go through. Let's ping ICE now. WLC was first, and they can't reach either of them. And a little bit of a more unique network we have configured is our identity pre-shared key network. And this is very useful for devices that can't easily deal with certificates. And so how this is going to work is we can have multiple users connect to the same SSID using a different password, and they get assigned different permission levels based on the password that they put in. So let's see exactly how that looks. They'll find the identity pre-shared key SSID, and this user is going to sign in with the password HBS cap 25. And what's happening in ICE right now, it's hitting authorization rule 2 that we have set up specifically for this password, and it's getting assigned to the network that we want. So let's check that here, assigned to 10.30, and then we can check in the ICE log to see the exact authorization rule that it hit and what VLAN it got assigned to, as well as the permissions. So authorization rule 2 it hit, and then we can scroll down to the network VLAN 30, and it's using that password. So let's go to another device now, and we're going to connect to the same SSID again, but this time using password HBS Capstone 25. So completely different password to that same SSID. And now it's hitting authorization rule 1 that we have configured for this specific password. And this time it's on the network 10.10. And we can check authorization rule 1 it hit this time, and then assigned to VLAN 10 using that password of HBS Capstone 25. So I'll hand it over to Chad to talk about duo multi-factor.
Yeah, so duo multi-factor authentication, there's many reasons to implement multi-factor authentication, but I think the main one is security. So, Duo will allow us to enhance the security posture of UDC so that they're better protected against attacks and things like that. And also, it's just a good, general thing to do to have multi-factor on anything that you can log into over the internet should have multi-factor authentication. Another reason is it's a very versatile program. It has many different applications that it can interface with, and you can secure remote logins and local logins, and it's also very easy to set up. So I'll actually show you right now just how easy it is. Sorry, I logged into it earlier, but it timed out on me, so just give me 1 second.
So of course, just like how we have to use multi-factor to log into our devices, we also have to use multi-factor to log into Duo administration. So.
Okay, so once you log into Duo, the homepage here, Okay, there we go. Sorry about that, folks. So here, this is the main homepage of Duo. So really, there's only a couple things you need to do to set this up. First of all, you have to add some users. So you can come over here to the left and go users again. You can see I already have some in here. The add user button's up here on the right-hand, upper right-hand corner. So I'll go into this, my username that I've already created. So the three main things you need when you create a user, you have to enter the username, obviously, and the important part here is it has to be the exact same username that the user would use to log in to the server, otherwise it won't work. And then you also need a working email that they'll use to enroll in the program, and then you also need the phone number that they'll use to authenticate with. That's really it for the users, and then you have to be protecting an application. So once you go to applications here, then protect an application. And for our purposes here, we're trying to secure remote logins. So you would just search RDP and then hit protect over here. And then the application will show up in the applications list. And this is where you can kind of configure it a little bit to your liking. You can set up different policies that you can go through, and like you can allow passwordless logon or enable offline logins, things like that. So you can kind of tweak it however you want. And then the important thing you're going to need on this screen, though, is these details right here: the integration key, the secret key, and the API host name. Because after you get this set up in the application, you'll download an installer program from the RDP documentation here. You'll do that on the server. And when you run that application on the server, it'll ask you for those three things, and that's what it uses to link up in the cloud. So and now I'll show you it working. So here I'm remoting into the server right now with my credentials. Okay, and then you'll see the Duo pop up there, and then on my phone here, I don't know if you can see it, but it pops up on my phone, so you just hit approve, and then it will log you into the server. And then I'll also show you what happens if you try to log in with somebody who's not enrolled in the users list in the Duo application. Okay, so I'm trying to, so this user, Peter Gibbons here, he has an account on the server, but he is not enrolled in the users list here, as you can see. And so you'll get the pop-up saying that user is not authorized for remote logins. So that is our Duo demonstration, and now I will hand it over to Ben, who will talk about Veeam backups.
All right. So picture this, if you will. Oh no, something is wrong with my server. It's not functioning. The VM, it's not working either. What can I do? I got to get it up quick. Lucky for me, and hopefully lucky for you, we have Veeam. Veeam is an application that you can use to back up and restore individual VMs or servers. That's what we use it for in our environment. You would configure it to point at a specific Hyper-V server. Then if you were successful in doing that, you could hit a backup job, click a drop-down associated with said server, and see the VMs associated with it. So this is a backup job I ran on 3 of our VMs, specifically the ones we use for ICE, the VWLC, and one for testing purposes, which I will kind of explain why I included that one in the next slide. But you can see the success rate, 3 out of 3. You can see the size of the backup. You can see when the backup started and how long it took. My favorite thing is that nice green bar at the top says it was successful. When I ran this the first time, I got an ugly yellow warning because I was running low on storage. So this is a restore I ran on the test VM. Why the test VM specifically and not ICE or the VWLC, would you say? Well, one of the first things you'll see when you try to run a restore is you'll see a notification that the following will be deleted. And because I did not want to chance that on our ICE or our VWLC, so I ran it on the test. But as you can see, you get green verification check marks as config, any files are copied over, and eventually you get a notification that it was completed successfully at the bottom. And before I move on to that, in a larger environment, I forgot to say this on the backup slide, I would have liked to set a scheduling policy, a retention policy, just because if you have to restore an object, it helps to be running these backups daily and have the most available data possible. Yeah, now we go to the next slide. So challenges. Me specifically, I live an hour away from campus, and of the hours we spent working on this project, almost all of them were in person. So anytime that I was putting in, like anytime that I had to use to work on this project, there was an extra 2 hours in driving. In addition to that, we all have jobs and we are all students. So for me specifically, I had to make sure I was scheduling my time really well. I'm going to work on this at this time, I'm going to work on this class at this time, and then I'm moving into Capstone.
So this right here, this was actually one of our first challenges that we had that gave us a little bit of grief early on. So I'll just ask you, you all, when you look at this password, do you see Big Co at 150 or do you see Big Cole 50? It's actually Big Cole 50. Okay, now that's what I saw when I first saw the password. However, that's not what everybody else saw. So I was in the back of the equipment. The first night we had everything racked up. We powered everything on, and we're trying to console in to this particular piece of equipment here. And they're telling me the password doesn't work. And in my head, I'm thinking that they're typing in Big Cole 50, and then it's not working. But really, they're typing in Big Co at 150, and that's why. So that just gave us a good bit of grief early on. I think eventually, though, I said something like, wow, I can't believe Big Cole isn't working, and then that kind of clicked the light on. He's like, that's an L? And so, yeah, so I guess the moral of the story is, well, first of all, don't assume that other people are doing what you think they're doing, and second would be, sometimes having a second set of eyes on things, they'll see something in a different, in a different way than you will, and that'll help you solve the problem, so, yeah.
And so this was our final hours. We well exceeded 600 after you include this week. And while sometimes we had silly challenges like the Big Cole, I promise most of our challenges were much more technical than that. And really the theme of our project was one of mental persistence. And what I mean by that is that there are many times where we would spend 6 to 7 hours straight in the lab and make what felt like no progress at the time. We didn't solve the problem we were looking to solve. So really it was about having the mental persistence to come back the next day and all of a sudden, boom, 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 a bunch of things start working at once. Because in reality, it's not that we didn't make any progress the day before, but we did find a lot of ways that didn't work, which in the end got us closer to our solution. And really, everybody up here had a big breakthrough at one point in time. It's something that we were stuck on for hours, so we're really proud to be talking about it today. And with that, we give one big thank you to HBS again, Dominic, Patrick, Abby, Justin, Tom, the CNIT Advisory Committee for watching this, and our great CNIT staff, Holly, for making the program what it is. We have people like Jackie and Judy who make the world go round. So thank you, everybody. And with that, we'll open up to questions. Yes.
First of all, guys, great job. That was all that good stuff there.
Thank you.
Going back to the crux of the original problem where a business burned down and you need to rebuild the network, were you given a budget to use, and is that why you chose the technology?
That's a good question. We weren't exactly given a budget. We were just given the equipment. But yeah, we definitely thought about everything that they needed to get everything up and running. So that included at the baseline servers, the network equipment. So we did everything with what we had. But yeah. Yes. Yeah, I think that would be helpful to see and kind of get in our head the amount of money it does take. I know the equipment is very expensive. So yeah, that would be a cool thing to see for next time, yeah. And with that, we'll pass it off to the Menards team. So, thank you.
All right, before we get started, I just want to once again thank everybody for coming out and taking the time out of your day to come and watch these presentations. It means a lot, not only to us as students, but to this program itself. And with that out of the way, we are the Menards Capstone Group, otherwise known as NSAT, the Network and Server Automation Task Force. And this is Infrastructure as Code, Automated Network and Server Deployment for Menards. So before we get into anything too technical today, I first want to go over our agenda. So first, we're going to talk about our team and who we are. Next, our sponsor, Menards. And then we are going to get into our problem statement that we were given at the start of the year. And next, our project goals and project deliverables. After that, our lab setup and lab flow. And that lab flow will just kind of give a little bit of background into what our live demo will be about. And of course, right after that will be our live demo, where we spend most of our time for this presentation. After that, we will all talk a little bit about lessons we learned throughout this process, and then stretch goals that we had if we have more time for this project, and of course, time for questions at the end. So introducing our team, my name is Tanner Sands, and I was the project manager for this project.
My name is Luke Lee, and I was the technical lead.
My name is Alex Hillblink, and I was the quality assurance lead.
And I'm Allie Anderson. I was our documentation manager.
Yeah, so moving on, we just wanted to say we were very lucky enough to be sponsored by Menards. If you don't know, they are the third largest home improvement store here nationwide. They have more than 340 stores. They have their HQ right here in Eau Claire, very close by. We were very lucky to work with their networking team. We worked with Justin Yarrington, Kevin Wagner, Tyler Lee, and Colin Weber. They're a great resource to use. They're a great group of guys to work with. They're very helpful when we just needed little nudges and little pushes to get the answers we needed to figure out our own and get any bumps out of the way that we had.
So I'm going to move into our business impact and the business issues. Menards came to us with a very large backload of projects coming in throughout their year, and these projects can be consistent of short-term and long-term, whether it's a virtual machine, DNS records, firewall policies, just a variety, and they all have different needs and different timelines. Because of this the backlog, they experienced a low completion rate and also a quality loss in those creations of VMs because they had to push them out as fast as they could. So they weren't able to customize them as much as they probably would have liked. And then because of this, also, the VMs are made, they're just left there, same with all the firewall policies and DNS rules, they're just sitting there. So it's eating at their resources, and that costs a great deal of money. Moving into the business cost and the solution, we estimated, these are all rough numbers, we came up with these on our own. We estimated that Menards gets about 100 projects a year, and they have about a team of 15 total, with it broken up into a networking team, a security team, and a server team. And we estimated that about each person had 6 projects to work on. Also, they do co-work on the projects together, obviously. But during that time, we assumed that for 1 week's worth of 40 hours a week, they worked on one VM and completed it and pushed it out so that it can be in production, which total per person, we came up with $120,000 for a manual creation, and our solution brings that down to only needing 1 person and 1 hour to create a virtual machine, which brings the total cost down to $3,000. This allows them for more customization. They can add in extra things that the user may desire for their environment. It also has an automatic deletion process, which reduces the cost for resources, and then obviously they have more time to work on other tasks that are not related to those projects.
All right, so getting into our project goals for this semester, we decided to split it up into 5 different phases. At the base of our pyramid, the first phase was just conducting basic research so that we could understand the tools and understand what was actually needed in order to be successful for this project. And then once we had a solid foundation for this, we moved on to the next phase, which is where we shifted our focus to automation, specifically with Python scripting and Ansible. This phase was also relatively short. We just wanted to understand the flow of how automation works. So we did some testing with how to automatically create some web servers. And then from there, we created a user-friendly form that just collects basic data in order to create the virtual machine. So this form just gathers, basic info like their name, their email, how many CPU cores they want, disk space, the list goes on, right? And then all of this connects to our back-end infrastructure, which leads me to the cusp of our project, our custom API. So this is where we did pretty much all of our coding, and this is where we created a numerous amount of scripts and playbooks that at the end of it is all able to efficiently create a virtual machine within the click of a single button. And so leading up to the top of our pyramid, which is just lifecycle management, we wanted to create a way to automatically delete those virtual machines that are being provisioned. So we implemented an expiration date within that user form I mentioned earlier. And then once the virtual machine hits that expiration date, it's just going to automatically delete. And so moving on to our lab setup. So our project is just hosted on a VMware ESXi hypervisor, and then we just installed that on an HP ProLiant server. We also just use Cisco switches and a Fortinet firewall router that was given to us by Menards, and then this is all just to simulate a real-world enterprise network. And then on top of that, we just had a Windows server within our ESXi host, and then this just acts as our main server for AD, DNS, DHCP. And then we also had a deployment virtual machine that was running on Ubuntu Linux. This is where we did, pretty much all our coding. That's where we run our scripts. That's where we run our playbooks, all of that. And last but not least, we also use GitHub for source control.
Yeah, so getting into our lab flow, this is basically our flow chart of how our code works. So starting off at the top, we have our main app. It's an app script. We run that. That is the first, and that is the only script you will have to manually run. After that script is ran, it opens a Flash server, which just opens a nice, easy, simple web page locally on that machine. That is where the user will input their data for whatever they need. So the VM name, how many cores you want to it, how much storage you need it, what firewall policies, whether you need RDP or HTTPS to go to that machine. Once that user data is inputted, it'll be extracted and pulled from that interface, and that is used in all of our code in our different playbooks. So once that data is extracted, it should go down to our preview request script. This is basically our master script. It takes the user data and runs all of our playbooks and everything else. The first thing that happens in that script is it uses that user data to create a custom ISO file or operating system file for either Ubuntu or Windows. And that then once uses that ISO file to make a VM. Once that VM is booted and it runs, it gets an IP address automatically from your local DHCP server, and then it will give that IP back to our playbooks, and then our firewall policies will run. Our firewall policies use that IP address so you can control the traffic to that new VM. And then if you were to choose an Ubuntu, so for like automatic web server boot up, we have an Apache playbook that runs, installs, and grabs your custom HTML file. So now I'm going to pass it back to Luke, and he will get us started with our live demo.
Yeah, so thank you. So as Ali sets up and remotes into our network, I'm going to briefly tell you guys what to expect from our live demo. So first off, we're just going to start it up from the top. We're going to submit the form, and then upon submission, it's going to automatically create the ISO. It's going to start booting up that virtual machine. And we'll also show you what's actually happening in the back end. And once that loads up, but yeah, once after that, then we'll sort of show you guys our Ansible playbooks and all of it being ran, and then we'll even show you, you know, the virtual machine getting booted up itself. So go ahead, Ali.
It seems to be a little slow this morning. We did have it logged in. Just give it here a little second. There we go. So the first thing I'm going to do is run our app script that Alex mentioned earlier. You can see that it starts with that Flask file. Then I'm going to transition into the actual user form where I'm going to start filling it out. I'm just going to give it a unique name. And I'm going to select the cores. And with this section, the cores, the RAM, and the disk size, we do have implementation in so that it checks to see that you have the required amount. So example, I can't select 2 for RAM. It's not enough, so it will tell you that when you try to submit. So I'm just going to do 16, moving down. I'm going to keep it as an Ubuntu ISO type, and I'm just going to pick a date. And then here's our firewall policies that we can select. I'm going to do ping, and I can add, and then I'm going to also do HTTPS and add, and then you can give a reason why you need this project. And then I'm going to go ahead and press submit. We can see it was successfully submitted, and then I will pass it back off to Luke to explain these messages that are coming up.
Alrighty, so as you guys can see, upon Ali immediately pressing that submission button, everything is now being ran through our backend API pipeline. So to start off, you guys can see like the information that was just submitted, it shows up into our console over here. And then what our script does is that it automatically extracts that data and puts it into a request folder and converts it into a JSON file. So what happens next is that our script then grabs that JSON file and converts it to a YAML, because if you're unfamiliar with Ansible, in order for it to run properly, it needs to be in a YAML format. So our script just automatically converts it to YAML into a file called a vars.yaml file. And this file is extremely important for all our scripts, our playbooks to work, because they pretty much all come back to this vars.yaml file. And as you guys can see, it contains, well, pretty much all the information that Ali just submitted. On top of that, it also contains a username and a password. So what we actually do is that upon submission, once that virtual machine gets created, it gets sent to that email with those credentials. You guys might also notice there's a password hash. In order for Ubuntu to automatically install, it needs to have some sort of password hash. It can't just use a plain text password. So if we go back to the console, I'll get into explaining the ISO. So We also have some conditional logic where if that var.yaml file has the operating system as Ubuntu, it's going to look for our Ubuntu scripts to generate that ISO. If it had Windows, it's just going to do and try to find the Windows scripts to generate the Windows ISO. And as you guys can see, the Zoraso update, that's just our Ubuntu ISO being generated. So passing it on to Alex, and he's going to show you guys the creation of the virtual machine, as well as the playbooks that will soon boot up in our console.
Yeah, so just like Luke was saying, the Windows machine works very similar to the Ubuntu. It just automatically creates that ISO and it boots it alongside of a normal Windows ISO installation. So now that Allie has gotten us into our EXSI, you can see there in the tasks, that is the new VM that she just submitted, and that task was successfully completed. And then if she can go into it here, we can see that Ubuntu is being installed and it is booting. The process of this, it takes about 35 minutes to kind of get completed. So we were able to go in and I made a VM ahead of time. And so Allie can go into that and kind of show us our custom username and password. So when I made this, my name is Alex Hilbelink, so the username is ahilbelink. And then the password was that randomly sent and generated password. So she was able to log in. So now, while that other one is booting, we will go back to the console. We can head back to the console, and we can see here all this output. This is from our YAML playbooks. You can see that all these were able to complete and succeed. As we kind of scroll down, you can see that it chose Ubuntu. You can see there it skipped that Windows upload because we didn't choose Windows. And as we keep going down a little bit farther, we should be able to see that it successfully created it, and now it's going to be starting our firewall policies. So you can see there it outputted the IP, so it got an IP already. As we continue down a little more, we can see, there we go, there's our firewall playbooks running, successfully going. And if you go down a little more, we should be able to see that it successfully sent an email to that email that you inputted. There at the bottom, you can see that we have an IP address, and then if we go over, we can get and look at the email that we should have just received just a couple minutes ago. There's our username, there's our password. Now you should be able to get into your new VM. So now I'm pass it to Tanner, and he'll talk about the firewall.
Yeah, thank you, Alex. So Allie gets logged in here to the firewall to show off the policies section. I just want it to be noted that this is for a testing environment and should not be used for a production environment, specifically these policies. It's just for testing purposes and proof of concept, really. So looking at these policies, there are two at the top. These are statically set just so that the network can talk to itself internally and reach out externally to the internet to get any resources or data it might need. There's also the implicit deny at the very bottom. This is just so that anything that we don't explicitly allow through a network will be dropped and not be able to pass through it. But looking right there at number 5, we can see that a policy was created. There are 3 fields that change every time with when the VM form is submitted, that being the source IP address, the schedule, and the services. First up is the source IP address. That's just the IP address that the VM was given by the DHCP server. So this policy will only affect that VM. Next up is our policy or our schedule. This schedule has 2 fields, the start date and the end date. The start date is just the day that the request was submitted. So today being the 9th, it's May 9th, and then the end date, and that is the day that Allie put in for the expiration date, being the 10th in this case. And then finally, our services. These are just services that are allowed for the VM to use, and Allie in this case used ping and HTTPS. So in the background, there's another script running. It's hard to show in a live demo, but this script just goes into the VM and looks for any outdated policies. And by outdated policies, I mean policies that are past their end date. So if the background script was ran on the 11th, this policy would be outdated because its end date is the 10th. So it goes in, checks for those outdated policies, and will delete not only the policy itself, but also the schedule and the source IP address, meaning there is no manual configuration required for this firewall. And with that, that concludes our live demo. We will now be getting into lessons we all learned. And for me, on the technical side, I learned a lot about troubleshooting. Of course, we do a lot of troubleshooting here at Stout, but it's all in a very controlled environment. And of course, you can ask the 18 other people or so in your class how they did it, how they found the answer to the projects or the labs we were doing. But for a project like this, it's just so much just looking for the right resources and asking the right questions to get the answer you need, because at the end of the day, there is no one right answer to problems like this. I also learned a lot about firewall policies themselves. When making, I was the main person on the firewall scripts. So when making the scripts, I learned not only about how to connect to it and make these policies, but also about Fortinet firewalls in general and how they operate. And on the personal side of things, task prioritization, it relates pretty much with project breakdown. Just going into a project like this, of this size, is something we've never really done before. So getting that experience to work with a real world business to help solve a problem like this is something we've never done. And just going in, breaking down a project like this, and being able to prioritize those tasks into what needs to get done first, what needs to wait until another task gets completed, and yeah.
All right, so I'm going to do things a bit differently. Before I share my lessons that I learned this capstone, I wanted to share just a quick story with you all. So last semester, I took an automation course, and Holly was the one who taught it, and it was awesome, right? However, when it came to coding, I struggled so much, because when it comes to coding, there's just some concepts that just don't click with me, right? So it was difficult to fully enjoy. So at the beginning of our semester, when we're getting assigned our capstone groups, I'm just crossing my fingers, please anything but coding, right? Ironically, I get assigned, well, pretty much a project that has purely coding for the most part. So I had to approach things differently, and it was also a great experience to be able to get hands-on collaboration with my team and the Menards group on a weekly meetings and stuff. There's also strict deadlines that put pressure on our group as a whole because we needed to produce results. And ultimately, it just allowed me it gave me a much deeper understanding to understand the importance and efficiency of automation. So for me as the technical lead, I was in charge of creating that front-end form as well as the beginning parts of our back-end API pipeline. So I created, all the data being transferred into all that stuff as well as the Ubuntu auto installation. And a part of that is just being able to be so concise and meticulous, because with code you have to be so precise. And as a personal lesson for such a big project within such a small amount of time, you really needed to focus on yourself as well as keeping the rest of your group in check. Thankfully, my group was amazing. We, communicated usually within just a couple minutes on a daily basis, and we all held each other accountable. And for that, I think we were able to, be successful.
Yeah. So for my lessons, basically Ansible. We did a lot with Ansible. That was main automation, and I hadn't worked with it really at all before this, and so figuring out how to use the YAML format and how to, Ansible has some different little code you can put in there so you can have conditions and stuff like that, and as well as all the different modules it has. It has a ton of different tools you can use to automate basically any other device you want. So I thought it was just super cool to see all this automation that you can implement. I also worked a lot with the Windows auto install, so that was super cool to see how much customization you can do with installing machines and having it have that unintended ISO build up right next to it, and you can do way more stuff with it than I thought you ever could. For personal stuff, I had to learn a good work-life balance. So about a month and a half ago, me and my wife, we had our first kid. And so as you can imagine, that brings in quite a bit of craziness into your life. So I was lucky enough to work with this team that they helped me kind of figure out that work-life balance of coming in, doing class, but also making sure I can be home and help out with my child. I was also lucky enough to work with a team to build presentation skills, to understand this concept and these tools, and then be able to present it to you guys, to be able to talk about it in a way and explain it in a way that someone who doesn't have any background knowledge can understand what we did and what our project is.
So moving into mine, for my technical, I did a lot of the remote connection. So how we connected into our technology here that is on campus, just down a couple floors in this building. Obviously, we can't directly connect to it from here, so I set up using Tailscale and No Machine to be able to remote in and give you a true live demo. And that had some challenges of its own, but it was a great experience that I can use into the future. I had more personal skills that I learned. I also did the documentation for all of our white paper. I had to learn time management. I have a very heavy class load this semester, so I was constantly busy trying to manage between all my different classes and all the assignments, making sure I'm staying within the deadlines, as well as making sure I'm keeping up with communication like Luke mentioned. I did very good with keeping up with our group, but not only that, also communicating with our sponsors, making sure that they were getting our weekly updates, and then also identifying priorities. That kind of goes hand in hand with the time management, making sure I'm doing the right things at the right time so that things are meeting their deadlines.
Yeah, so moving on to our stretch goals. Our first stretch goal is load balancing. This is actually a stretch goal that Menards gave us at the beginning of the project, but as things progressed forward, we just didn't have enough time to get into it to be able to load balance these VMs. But it was something we would have liked to get to, not only for Menard's sake, but also just to experience that technology, as I'm sure that not all of us here have not had a ton of experience with that. And then the second one is the virtual machine deletion. We spent a ton of time troubleshooting that, but we were just unable to get that working. But I'm sure if we had more time and had more concentrated effort into that aspect, we would have gotten that working as well. So some closing remarks. Our automated solution would take a process that would take multiple people across multiple teams. That would take hours for each VM to be created, to take roughly 30 minutes for one person just by submitting that form. And these 30 minutes aren't even spent putting in inputs. It's just filling out that one form and then waiting for that email. And once you get that email, you're good to go. You're good to start doing whatever you need to do with that project. Also with this is there's little to no manual input, and this means there is little to no human error. We're all human. We all make mistakes, especially with things we get comfortable doing because we've done it 100 times. So when we do it that 100th time, we make that one little misclick or that one little misinput, we make a mistake, and we have to spend time troubleshooting that and figuring out, and that just adds more time, which loses more money. And overall, we've calculated that this would save roughly $100,000 a company if they were making 100 of these VMs per year. And in 10 years, that's $1 million. How much is $1 million worth in 10 years? Don't ask me. I'm a CNIT major, not a business major. So with that, I'd like to thank you all once again for showing up and listening to this presentation. I'd also like to thank our sponsor from Menards for giving us this project to work on for this semester. Also our supporters. I'd also like to thank the CNIT and Cybersecurity Advisory Board and faculty for putting this all together and making this a success that it is. So once again, thank you. Now we have time for questions.
Yeah, so at first you had kind of nudged us in some ways of Terraform, and so I had researched that, and it looked good, and I was trying to figure out how to implement it. And the sponsors that Terraform had was vSphere specific, I believe, and so we didn't have that on our system, and so it just didn't quite work. And then in Terraform, you have to then use all these other tools. You would have to even use some Ansible anyways to automate some of the processes and some Docker situations with the VM templates and all that. So I was able to just kind of research, and I found Ansible. I mean, it's a huge hugely used program. There's a ton of modules for it. There's a huge community around it, and I just found some simple stuff on it, and I was researching it, and I tried it out, and it worked super well, super easily, and so that's just kind of how we stuck on it. Yeah.
All right, if there's no other questions, once again, thank you.
Hello, everyone. This is automating leaf spine architecture using Naudibot, presented by the Network to Code 2025 Capstone team. So let's meet the team.
So up at the top, sorry. Hi, sorry. So up at the top, I am myself, Jacob Swantz, the project lead for our project.
My name is Chris Blount. I am one of the automation engineers on the team.
My name is Nathan Hammer. I was the other automation engineer on the team.
And my name is Eli Junko, and I was the operations manager for the team. In addition to the team, we had 3 outside assists for this. The first one is Will Gross. He is our Arista contact. In the middle is Holly Wan. She is our program lead. And then on the end is Josh Vandere. He is our Network to Code contact. Speaking of sponsors, we were sponsored by both Arista and Network to Code. Arista is a networking company that specializes in high-performance networking. An example of this is in financial institutions. They also help power software-defined networking. And then we have Network to Code. They help sponsor Naudibot, which is a leading open-source, single source of truth. And they also help provide consulting and professional assistance to network automation.
All right, so going into the legacy network, the deal with the sorry, yeah, I forgot you had one. All right, so going into the legacy network, one of the big things there is that networks of the past can lead to a large amount of downtime and costs, considering the fact that you're having to deal with inconsistent configurations, some limited scalability, and compliance risks. So going into that, you need to make sure that the networks of the future are able to fix those problems.
In addition, modern networking requires a lot of new things that we didn't really need until, past 10 years. One of those things being agile deployments. You need to be able to quickly add, remove, change whatever you need about your network as quickly as you can. Stuff moves fast now. You also need to have something that is highly flexible, highly scalable, something that at a whim you can go, oh, need 100 devices, let's go. It's hard to do that when you have to manually enter everything and go into the CLI yourself. And the other thing, as one of the earlier groups talked about, stuff needs to be vendor agnostic. We're using many different switching companies, many different products, all sorts of these different companies. Think, Cisco, Arista, Aruba, Juniper, all these players in the marketing space, they have a lot of different things that they need, and they all do things very, very well. So how exactly do we solve this? That is with network automation. Network automation allows you to do more in less time with higher reliability. Network automation allows you to essentially, that's what happened. They allow you to optimize your costs so that you can spend more time doing other things. You can spend more time working with more clients. They allow you to, as I was talking about earlier, have a more scalable solution. And they also allow you to have to stop doing repetitive tasks because no one wants to have carpal tunnel. That sucks. But one of the things that we're going to be doing with that is using Notabot as our source of truth. This is where all of our information is held, including device types, device life cycle, interfaces, IP, any of that information is all in Notabot, and we can pull that and automate that and apply it to the devices as we need to. It takes away the specialness of a device and putting it into a central repository of information.
All right, so going into the project goals, our overall goal is to implement a layer 3 leaf spine architecture. And in so doing, we're able to research the existing Arista equipment. That will allow us to gain more experience in the world of networking. As a part of that, we want to simulate some real-world scenarios as a part of that, as well as demonstrate network automation fundamentals.
So for our deliverables, the first one that we want to look at is making a single source of truth using Notabot. Essentially, any kind of important information that would need to be configured on the device when it comes to networking, we'd want to have within Notabot to double check and make sure that whenever we apply configurations to these devices, that's all in there. For that, we're going to use a dynamic inventory through Ansible. So we're going to have a plugin developed by Notabot that utilizes in Ansible to take device information from Notabot, take it down, and then run against these devices as so needed. By doing that, we can then deploy configurations using this dynamic inventory and the information within Notabot. Going forward, then, we're going to want to look for compliance. So we want to make sure that we have our intended configurations within devices compared to our backups so that we can see if there's ever any kind of straying away from the compliance that we have set up within Notabot, that we can then go through and see against like 100 different devices which ones may not be compliant and which ones will need to have changes applied to them. Along with that, then we have our CI/CD pipeline that we have with any kind of configuration files that we have. So like Ansible playbooks, any kind of Jinja templates that we need to have some sort of way to make sure that we have that checked before we go ahead and then push that out through any kind of configuration changes. And then finally, within Notabot, we first of all want to have backups, as mentioned prior, especially when it comes to within Notabot, just so that we have a space so that we, in case a device goes down, we have a backup that we can go back to. A routing dashboard so that we can see all kind of important routing information and have that stored for each device within Notabot. And then finally, a generalized dashboard to see any important information that we'd want on these devices as needed. So then the specific technologies we're looking for our infrastructure, we have everything within Google Cloud. We have 3 different VMs put up, one for Ansible, one for Container Lab, which runs all of our devices, and then one for Notabot itself. For these, we utilize Linux. We have a mix of Ubuntu and Debian for our different flavors of Linux that we utilize within our infrastructure. And then finally, we use CEOS, which is the containerized version of Arista's EOS networking operating system. For the applications we use, obviously, we would utilize Notabot here for our source of truth. We utilize Container Lab so that we can stand up devices virtually. And then finally, we utilize Ansible for pushing configurations to devices and then taking a dynamic inventory for those devices. For our CI/CD pipeline, we're primarily focused on linting. So we utilize YAML-lint and J2lint, which is written by Arista. And then we obviously have our information stored in Git. Specifically, we have it stored within GitHub.
Talking about the technology, the specific network we decided to spin up, we went with a leaf spine architecture. We went with this because of its rapid scalability. You can add, remove leaves and spines as needed. In addition, Leaf Spine also specializes in east-west information and travel, as well as north-south, and it's very compatible with all of your favorite protocols: OSPF, IS, and BGP.
Cool. So going into the project timeline, the project mainly focused on 4 initial phases. The first one being between Nautobot and Ansible, getting those stood up and all the code written for that. Going into phase 2, that was the overall scripting, as well as setting up golden config. Going into phase 3, that was the deployment of our CI pipeline, and that by far took the longest time of all of it. And then finally, finalization and testing that allowed us to make sure that all of our scripts were working, everything was connected, and everything was going great. As a part of that, we also had our lab set up. So we created 3 different virtual machines focusing on Nautobot, Container Lab, and Ansible. And then for our code configuration, making sure that our push-pull requests were all handled and taken care of, we used GitHub.
So we will go ahead and move into a live demo. So as we get this moving, first we are going to move to Container Lab. So as we kind of talked about, one of the great things with Container Lab, what did we lose? Oh, I think I know what happened. Why did we lose?
Is the dongle not working?
Oh no, we lost display.
Oh. Yeah. Do we have any IT professionals in the building? It's like when you're on a plane and it's like, is anybody a doctor? You're going like to veterinary conference and you have like 15 people raise their hands.
I did that. I did that. I promise.
We should turn off the entire laptop and turn it back on. I don't know if you all know this really old show called like IT Crowd, I think. It's like, all right, calling the IT department. Have you turned it off and turned it back on again? And they eventually just set up like a whole marketing little automation that was like.
As it always is in networking, everything works fine in testing, and then you try to move it into production, everything fails.
We got it? Let's go, ETC. Love those guys. Thank you.
This is for you. Turns out you need to have the display on. Windows needs to at least use the display to know what's going on. Anyways, so back to what we were going to. The entirety of our automation is handled inside of a Container Lab YAML file. One of the great things about Container Lab is that you can set up and spin up any kind of, sorry, I can't think and type at the same time. There we go. So essentially in here, what you can see is how our entire topology is laid out. So we have a management network, which allows us to basically SSH into the devices and manage them as that, the name suggests. We can tell it what image we want to use specifically, what platform we want to have our devices use, and then we can also have all of our endpoints. So how it's all going to be, essentially think of these endpoints as just cabling them up. But instead of doing it physically, it's all virtually, and it's all just a file. Great thing about that, very easy to iterate on something, very easy to test something, very easy to change however you want it to go. So if we do real quick, I can type.
I can like hold it for you. You can do this too.
That's good. There we go. So you see all of our Docker machines that were all spun up. But I will then move it over to Jacob to kind of go into actual Nautobot interface itself.
Yeah, cool. Yeah, so up at the top, Nautobot being the little, GUI that we have set up. And essentially in here, with this virtual machine, we're able to gather up all the information. This is our single source of truth. So going into devices, if we were to look in here, we have all of the current devices that we have simulated inside here, all their little names as well as their type. So we were mainly focusing on learning the Arista gear. So we created 8 virtual machines using the Arista products, as well as the location and their IP addresses.
So I'm going to move into the initial configuration for Ansible. So here's our Ansible. And we have a couple files in here. Our Nautobot inventory is our dynamic inventory file. We have our deployment, which is the playbook that we utilize to run. And then within our deployment, once I get going here.
Yeah, I gotcha. I'll do this for you.
So while this is running, I'm just going to explain what this does. So the first thing it's going to do is take our dynamic inventory, contact Nautobot, say, hey, we're going to run against all 8 devices here. I'm going to take down all those devices, and then it's going to start running. So the first thing it does is it sets variables for the GraphQL query. What we're going to do is query Nautobot here using GraphQL to go ahead and get important device information, which includes our interfaces, the BGP config, and then any kind of services we want to have on it. By doing that, then we're going to render a Jinja 2 template that we have within here. It's going to go ahead and render it for our leaves, and once our spines are done, and now it's going to go and SSH into each device and apply that config. So of course, this is going to take, everybody knows that network automation takes really fast, so it's going to take a bit of a moment, especially for our spines, which have quite a few BGP peerings it has to link up here. But while I'm doing that, Eli, if you want to go ahead and just go over our hardware reporting.
So we will jump back to Nautobot while this is going. So in a data center, it's very common to not only have hundreds of devices, but also have those devices be bought different years and have a life cycle report saying maybe this device can only be in service for 5 years, for 6 years. How do you track that? Nautobot has the answer. So if we go to device lifecycle, this is a plugin we added to Nautobot. We can go to device hardware notice report. And here we can see we have 8 devices. These are the leaves and spines. We can see there are 7 in compliance, that is the green, and 1 out of compliance, that is the red. This simulates, as everything is virtual, I had to manually put this in. But this simulates what it would look like if a device was out of compliance. Additionally, we can see that this was last run 6 hours and 17 minutes ago. This was done automatically. This is a job that you can automatically schedule to get daily, yearly, monthly reports, however often you want this job to run. Additionally, on the right, if you'd like in a professional setting, you can really hone in on the specific data point you want. Say you want to look for something that's end of sale, you can simply input that on the field and you would be good to go, and it would filter the entire device lifecycle based off that query.
I'll take it back here just for a moment to show the output of our Ansible playbook. So you can see no errors, everything went fine. We're looking great here. We're going to go in and then do you're going to have to do it. We're going to go into device quick and just see the show run showing that we can get into the device and then just see that our configuration was applied from there. It's going to take a moment for him to type it out. I'm going to go in, everyone enable, show run. I wish I could just type show and it would show us.
I know, it'd be great.
So you can see here, we have configurations for our interfaces. And then if you continue to go down, we have our router BGP information in there as well. And then certain services that we have, such as our NTP server. And then if you scroll up just a little bit.
We'll just do it like that again.
There you go. Then stuff like our service routing protocols, then like our time zone, and then stuff like, and then management SSH, which we already had configured.
Yep. So moving into, we'll go into golden config. So this is kind of the meat of a lot of the stuff that we've been working on here. First thing that we're going to do is we'll have all of our devices. All these devices are listed in, again, it just pulls it from Nautobot. What we'll do first is we'll create an intended config. And so what this is doing is in GitHub, we have essentially a file, it's a Jinja file, that has all of the configuration that we want to apply to our devices. So in this case, we can say, where do we want this job to apply? You can get as detailed and drilled in as a device itself. In this case, we're just going to use a platform. You can turn on debugging, you can tell it to fail, you can give it a funny Git message if you want to do that as well. And then you can either run it immediately or have a recurring schedule. So we have a recurring daily schedule of backing up our configs. But what we'll do, just run a job. This will go out, this will create based on our generated intended config, and it will show that it completed. We can scroll down, we can see it was able to reach everything. So all of the stuff is, as I said, was inside of GitHub. You can use whatever source control thing you want to use. You could use GitLab, Git, whatever you want to do. It is all supported. The other thing that we can then do is we can do our backups. So same kind of idea. We can go through and we can choose our platform and we can run a job. So that'll go through, it'll contact each device, get its SSH, it'll SSH into it, get its information. And the great thing is that sometimes, what's really, really great is if something goes wrong, it gives you a lot of great detail into actually explaining about, what went wrong, why something went wrong. It's really great for that. And it helps you really, troubleshoot when you need to do stuff. And it's a lot quicker than manually going into a device trying to figure out what's going on there. And then finally, I will hand this over to Eli to talk about the compliance.
So, much like the rest of Golden Config, compliance is run simply from this. We will go into platform, this is COS, and run. So what compliance is looking is we can set certain rules. Say we want a specific NTP server set, say we want SSH only, any type of rule we want to set. Notabot can check the current configs against the rules we set and see what's all in compliance and what is not. So what does that look like? I am glad you asked. So right now, everything is out of compliance. So what this is showing is our compliance is all out. So all this is saying is what the Notabot is looking compared to the rules is not matching what is in the intended config. Ideally, in a actual production environment, you would want all greens. It would seem today our Notabot is telling us that all 8 of our devices are out of compliance. Looking specifically at the rules that we set, we have AAA authentication, DNS, NTP, and SSH config.
So I'll finish this off by talking about our CI. So we utilize GitHub for our CI, and specifically within our CI, the first thing that we were looking for was specifically linting. As I said before, we utilize 2 different programs for our linting. We utilize YAMLint and we utilize J2lint. So as you can see here, we had a successful CI from the last push that we had to our main. This workflow will run anytime there is a push to main or any kind of pull request that is made to main. So we'll just go ahead and click on the details here to show. So essentially how it works is that it goes and sets up a Python environment, installs the necessary library, in this case YAMLint, and then it runs it on the repository. So in this case, it's just the YAMLint period, which just runs it against all of the YAML files that are in the branch. No problems came out of it. You're going to have nothing there. So that job is completed. Next, it'll go against our Jinja templates, which are the ones in the repository here, are the ones that are run to create the intended configuration in Golden Config. So it'll run it against that. And then I also have a Jinja template within the Ansible folder that has a little bit of a different data structure due to how Ansible handles the GraphQL query when it comes in. So it's run against that as well. No issues in there. So that job is also completed.
Awesome. After the live demo, let's go into lessons that we learned throughout the project, some issues that we encountered. One issue that I encountered very early on into this project was we were suddenly and inexplicably unable to SSH into our VMs. Initially, I thought this was a firewall issue or something with my home internet, but after doing some looking around Google Cloud and having some assistance with the inbuilt helper, we found out that the VM that I was unable to SSH into was far exceeding the resources that I initially allocated to it. When I initially spun up these VMs, I limited the resources just so we were not burning through our credit. But turns out when you have a fully set up Notabot, it exceeds the bare minimum resources needed to run a VM. Thankfully, this was a very easy fix. All that required is spinning down or turning off the VM, adding more CPU, adding more RAM, turning it on, and all of a sudden, we were able to SSH into our VMs.
Yeah, so another issue that we ran into was we were struggling to get IP routing to work. What a fun topic that is. So one of the things that we were running into is our Ansible VM was having trouble reaching our devices themselves. They were not able to ping them at all. They couldn't talk to them. It was really weird. You know, we were able to get it to talk to, you know, we could talk to the actual host machine just fine, but we couldn't talk to the containers. And so initially I was like, okay, well, it probably just needs an IP route to be set up. So went into Google Cloud and got that all set up. Well, I was going to get it all set up, and then I was told with wonderful information that I didn't have the option CAN IP forward turned on. Now, the great thing about CAN IP forward being turned on is it allows, you know, that device to forward any traffic that it gets to itself. This can be turned on the first time that you create the VM, and never again. I don't know, whatever. Luckily, what's great about this, it was a very simple fix. All it took was essentially deallocating the boot VM that we were using, then it was just remaking the VM with the option turned on, and then putting the boot disk back onto this new VM, everything spun back up, and it worked just as fine. The IP route started working, our Ansible VM could start talking to our containers, and it ended up pushing us along. But that was a long time to figure that one out. That was quite a bit of a struggle there.
Cool. So my contribution to the project was mainly focusing on the PowerPoint and the Visio. As a part of that, learning how to use the Visio program as well as the industry standard networking symbols that were provided to us by Arista. Thank you. You know, I went from learning not quite a lot about Visio to an uncomfortable amount about Visio. So please don't talk to me about Visio ever again. Thank you.
And finally, because I worked on both the Golden Config and the Ansible deployment, I worked with the Jinja templates for both. And I figured when I was making it that the data structure in the responses for both of them would be the same. I am wrong. In fact, these are two different applications that have two different ways of handling the data. Specifically, Nautobot trims down a bit of the data response when it comes to like the exterior sections of the response. So it is, in my honest opinion, that you should probably figure that out when you're making it, because otherwise you're going to be spending a couple hours troubleshooting something if you just read the documentation on it.
So I noticed that we're all itching to get out of here, and it's about 3:30 now. So I'm going to go really quick. Stretch goals. These aren't Kickstarter. This is for our project. What we were looking for is our first task, if we were to continue this project, is to deploy open source telemetry for live reporting. That's essentially being able to go into a device live and be able to see its status on its interfaces, speed, uptime, downtime, that sort of thing. Second thing on there would be the automate adding devices to Nautobot. At the moment, when we have our device creation script, we have it set up manually so that it creates 5 leaves and 3 spines. In the event, what we want to do in the future is to be able to take the devices and be able to automatically spool up new devices or bring them down depending on the amount of traffic in the network. So, you know, let's say we have to add 50 new users, we can add 2 new switches and a spine in order to make sure it all works. So,
do we have any questions? I would love to hear from you.
I got one.
Yes. It does. At this point, we couldn't get that quite working, but there is an option. They are called config plans. You can basically spin up, you can create a config plan, you can get, what kind of plan you want, whether it's making sure it's intended, any devices that are missing this, anything that has a remediation, or you can even do a manual one and what you want to apply that onto. So this is an option. We just, unfortunately, we're having struggles getting it to work 100%. But this is an option that is very nice, very easy to use.
Also, with the configuration templating, where is the source for any variables you may have to add? Is that just built into Notebot because it is a source of truth?
So within the GraphQL response that we get, a lot of that data is stored within Nautilbot. Essentially, it's just taking that and then using that query to then bring that down into the template.
Well, if there are no other questions, real quickly, if you are interested, you can scan these QR codes. You can read more into about what Nautilbot is, what Container Lab is. I'll leave that up for a little bit, yeah. Final thing, though, we want to say a big thank you. There's a lot of things I want to say thank you. First of all, can we please give a round of applause to all of the Capstone teams? They did an incredible job with what they did. I wrote this down. So, a few other things. We want to say thank you to the advisement board for looking at these presentations. Want to say thank you to all of the professors that worked tremendously with their knowledge and skill and their passion to make us be some of the best professionals. I want to say, thank you specifically to Holly for being the program director, really working hard to, bring everything together. I want to thank all the sponsors. For us specifically, we want to thank Will Goss. We want to thank Josh Van Der Ray for being our sponsors. They helped us, understand what we were doing here, because there's points where we didn't know what was going on. It was fun, but they helped us. They guided us to get us to pointed in the right direction. And I'm sure this was the same case for a lot of the other Capstone groups with their sponsors as well. I want to say thank you to all of the people who are watching online. Even though you may not be able to be here today, it's very awesome that we can see, that you're willing to watch us virtually and cheer us on. And finally, I want to say thank you so much to everyone who came here today. We worked a lot of nights getting a lot of this together, all the Capstone groups. We spent a lot of months, but this isn't just, showing what we've done the past few months. This is showing what we've done over the past years, 3 years, 4 years, for some, including myself, 5 years and beyond. It was a lot of work. It was a lot of tiring work, and the fact that we can sit here and you guys are here to see it, to cheer us on, it really gives us a really fun opportunity, and I'm very, very, very thankful to everyone who's willing to do this. So thank you so much. Just real quickly. I wasn't sure which order I wanted to do this because I have announcements and I didn't know which way I was going to go about it. So we have 2 announcements. One of the big things is that all of the presentations, including white papers and stuff, will be sent out. I believe it should be over an email. Again, I believe the VOD should also be live on YouTube. And if you ever want to come back to this, feel free. It should be up there. And then the other thing is that there'll be an informal celebration that is going to be taking place down at Silver Dollar. That, in case you are not aware of where Silver Dollar is, if you go that way and then you go north onto basically Main Street, it'll be across the street. It'll be a little have like a black sign. If you don't know, use Google Maps, or I'm sure any of the Capstone people or any alumni can tell you exactly where Silver Dollar is, because definitely been here more than a few times, I can probably guarantee. So with those 2 things, I want to say thank you. So again, very awesome. Thank you so much to everyone.